Welcome back to Concepts in Arithmetic. We are going to finish off the long division algorithm in this video. If you look back to our previous two videos, we introduced the long division algorithm using single-digit divisors, and then we reviewed the idea of estimation, which comes in handy when you're doing long division with multi-digit divisors. So we're going to finish things off and work with these multi-digit divisors. So we'll just start out with an example here. There's a relatively small multi-digit divisor, 13. So we're taking 4,212 divided by 13. Okay, so 13 going into 42. Looks like I can fit 3 copies of 13 in there. Okay, now this is pretty easy to work with mentally, just finding multiples of 13. So I'm thinking 13, 26, 39. If I go any further, I would exceed 42. So I go to 39, which is 3 copies of 13. So I've distributed 39 things. I've got 31 left over. Looks like I can get 2 copies of 13 in there. 26 things. 52. And, oops, sorry, I forgot to write out my quotient there. And, okay, lo and behold, the division comes out even. So the quotient is 324, the remainder is 0. Okay, so don't forget the interpretations of what we're doing. Okay, if we were dealing with the partitive interpretation, we would start out by thinking about, okay, we want to distribute $42 to 13 people. Where am I getting 42? Well, it's right here, right? 42. You distribute $42 to 13 people. Each person gets $3. We distribute 39. And then we make change. Because when we distribute the $39, we would have $3 left over. And then we trade those $3 in for 30 dimes. Right? Distribute the dollars, distribute the dimes. Oh, looks like I'm in the way. Yoink. Okay, so distribute $42 to 13 people. Well, we can't quite distribute 42. We'll distribute 39 and change the remaining $3 into 30 dimes. And we already had 1, so now we got 31 dimes. And then we keep on doing that. Don't forget the measurement model either. Okay, our divisor is 13, so we start out by thinking, okay, what's the biggest leap we can take? We're talking about something that's around 4,200. So our leaps should be not 13, not 130, they should be 1,300. Okay, we're wanting to get to 4,200. I guess we're really wanting to get to 4,212. And if we take 3 flying leaps of 1,300, that'll get us to 3,900. And then we focus on the remaining bit, okay? Whatever that is. And that little bit is actually 312, I guess. Okay, so now we're taking leaps of not 1,300, but 130. And we can fit 2 leaps, and then so on down the line. Okay, so don't forget the models, even though we're wanting to get our students to make the transition to writing things out just with numbers. Okay. Let's do another quick example here. Let's take a little bit bigger divisor. 19 divided into 1,558. Okay, so The question we're asking ourselves right now is how many 19s in 155? Okay. Ah, gosh. I'm in the way again. Maybe I'll be out of the way over here. Let's try this. There we go. Okay. Okay, how many 19s in 155? Okay, so, well, I don't know. That's hard. What we do is we estimate. Now remember, estimating is we are going to trade this problem in. We want to make something a little bit easier. So we're going to do 20 into 160, okay? See where I got the 20? Just rounded 19 up, and I rounded this up, okay? Now it's really a one-digit problem, okay? 20 going into 160, that's easy, 8. So let's try 8. Okay, well, I got to do 19 times 8. Well, 20 times 8 is 160. 19 times 8 is 152. I just started with the 160 and backed off one of the 8s, right? 20 8s gives me 160, so 19 8s would be 8 less than 160. Okay, so now we're here. 38. Oh, okay, that look at that. That worked out nice, because 2 times 19 is 38. So when we subtract, we get 0. Okay, so the quotient is 82, the remainder is 0. That was a neat little use of estimation when we're working with a multi-digit divisor. Okay, let's do another example here. So we want to do right now we want to do 28 dividing into 207. All right, 28 dividing into 207. Well, we'll do an estimate. Make that a 30. Now you want to make this something compatible, okay? Don't go and make it 200, because 30 dividing into 200, that's not an easy mental math problem. Okay, we want to do something like 30 into 210. Okay, that's easy. 7. 30 would go into 210 7 times. Notice I made it a one-digit problem. I'm really dividing 3 into 21. Okay? So let's try that. Let's try 7. Oh. Let's not make it just a 3-digit. Let's make it a 4. Let me put an extra 6 there. Okay. So same idea though. We're estimating that it's a 7. And the 7 would go over there. Okay, I have my 7 in the wrong spot here. Should have been there. Okay, so my 7 should go here. Okay. All right, 7 times 28. Let's do a little mental math. That's tough, 7 times 28. 7 times 30 is easy, it's 210. So I need 2 fewer 7s. So start with 210, take away 7, you're at 203. Take away another 7, you're at 196. Okay, so 7 times 28 is 196. All right. And we get an 11. Now we're at 116. Okay. So what do? Once again, we do another estimate. Okay. Instead of doing 28 going into 116, we think about this. We think about 30 going into 120. Our estimate is 4. Okay, so that's 80 and 32 is 112. Subtract, we get a remainder of 4. Okay, so At each stage, we're doing estimates here. Now, here's what you need to do. When you're doing these estimates, you do have to make sure you check what you're doing. Is the remainder, so we're looking at the remainder that we get, the leftover part, is it greater than 0? Otherwise, we've gone over. Right? So when I do this first subtraction, the leftover part was 11. I got to compare that to 28. My divisor. Okay, so is the remainder between 0 and whatever your divisor is? If yes, that's great. You keep on going with the long division process. In other words, you make change, by shifting to the next place value. Okay, so that's what you do if your check is fine, but what if it's not? Well, if it's not, revise the quotient. Okay, change what you did. By adding or subtracting 1. Add or subtract 1. Let me give you an example of what that might look like, revising as you go. Okay, so in this example, what we're going to do is we're going to take 26, and that will get divided into 2095. Okay, 26 into 2095. So we're going to look at our estimates. Okay, we want that to go to a nice round number. Okay, rounding to 25, okay, it might help you, but I would probably go to a one-digit thing and say 30. And let's make that 2100. That's the exact same thing we were doing just a second ago. And we decided, okay, that'd be 7. So let's try 7. Okay, 7 times 26. Well, 7 times 20 is 140. 7 times 6 is 42. So 182. How did I get the 182? Well, I took the 140 plus the 42, okay? That's the distributive property at work right there. Okay, so I do my subtraction. And what I get is, I get a 27. Okay, notice my divisor is 26. Okay, what I'm looking here is this number should always be between 0 and 26. It's over 26 in this case. So I'm going to revise my quotient. I'm going to make that an 8. And usually what I do is I just subtract another 26. You already took away 7 copies of 26 by doing this. Looks like you take away one more, so you've taken away 8. So you got 15 left. Okay, so that's a 0. So the quotient, in this case, is 80, remainder 15. Okay, so that's an example of revising this algorithm as we go. We're using estimates to help us figure out what to put up top. And then when you're using estimates, well, sometimes it's a little off, right? That's what an estimate is. Okay, so you got to sometimes revise it as you go. And what you need to be looking at is this number that you get when you subtract. It should be less than your divisor. If it's not, change it up.